Okay, hi pre-calculars. I hope your quiz was good. We're moving on in our trigonometry unit, and our goal for today is to review the trigonometric functions, a sine and cosine curve, and how they get horizontally stretched or shrunk, the amplitude stretching it vertically or shrinking it vertically, how to adjust our graph based on this. So these two things right here should be a review, right? So the period for sine and cosine are 2 pi, the amplitude, it goes up to +1, down to a minimum of -1. Here's the period. The midline is the x-axis if there haven't been any vertical or horizontal changes. Remember, the sine curve starts at the origin, then goes to its maximum of 1, then down to its minimum of 1, and then back to the midline. So the 5 points we're really focused on here are what happens at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember the domain and range. The domain for each is all real numbers. The range is from -1 to 1. So really what we're going to focus on is the tangent curve, because you have not really talked much about the tangent. Sorry, before I do that, there's one thing I did forget, and that is to emphasize an even and odd function. So the sine curve is an odd function because it is symmetric with respect to the origin. That means it has rotational symmetry, right? So if you turn your paper upside down 180 degrees exactly, this little part right here will end up over here. And so with respect to the origin, you would see this blue part of the curve exactly the same. Or this little part here, with respect to the origin, would become over here. So we spin our paper 180 degrees, then you would still see the exact same sine curve. The cosine curve is an even function, so graphically, what does that mean? It means it has symmetry with respect to the y-axis. If you folded your paper right down here to the y-axis, you would get this part of the graph lying exactly on top of the other side. So cosine curve is an even function, sine curve an odd function. So what is a tangent curve? Is it even or odd? Well, first of all, let's just talk about how we get the tangent curve. What I want you to do is maybe pause right now and sketch the sine curve and the cosine curve on this particular graph. So I'm going to do that. I'm going to color, because I like color, I like visual. So I'm going to pause, I'm going to graph the sine and cosine curve, and we're going to talk about how that creates the tangent curve. If you have time yourself, I would go ahead and pause and do the same thing. Okay, so here you can see I graphed the sine curve in pink. I graphed the cosine curve in orange. Just looks a little wonky through here, but that's okay. So here in black is the actual tangent curve, right? So this is my tangent curve. So if we recall, tangent is equal to sine of x over cosine of x. So all I'm going to do is I'm going to look at the y values for sine and cosine, and I'm going to see what happens. So here, every time sine is equal to 0, well, 0 over anything is going to equal 0. So every time sine is 0, that means my tangent curve has to equal 0. So every time this pink curve goes through the x-axis, my tangent curve has to go through the x-axis as well. Now, if we think about it, if every time cosine is 0, right, and sine is any other number other than 0, well, can you have 0 in your denominator? No. Therefore, this is equal to an undefined function. We call that undefined, which is why every time the orange curve or the cosine curve goes through the x-axis, that means cosine is equal to 0. That's undefined, which then creates a vertical asymptote. So that's why we have our vertical asymptotes here. Now there are two other values that are really important to our tangent curve, and that is when both sine and cosine equal each other. So when sine and cosine equal each other, then they're going to equal 1. So when do the two graphs cross each other? Well, right here, so that has to equal +1. Right here, they cross each other, so they have the same value. They have the same negative value. So when they have the same negative value, they equal +1. When they have the same negative value, they equal positive 1. Then over here on the left-hand side, when they have the same y value but opposite signs, so a positive y value, a negative y value, which happens at pi over 4, right? Sine of pi over 4 is 1 over root 2 or root 2 over 2, and cosine of pi over 4 is 1 over root 2 or root 2 over 2, and so up here this is positive root 2 over 2, this is negative root 2 over 2, and when those two values are the same, we get a negative 1. Sorry, they're the same but different signs. So same y values but opposite signs, we get a negative 1. So that is why my tangent curve looks something like this. Now, we identify the period based on when that curve begins to repeat itself. So when does the curve begin to repeat itself? Well, every single section in between my two vertical asymptotes is the same. So how long is that section? Well, this is negative pi over 2 to pi over 2. Therefore, it repeats itself every pi units. So the period for a tangent curve is pi. The asymptotes occur every pi over 2 units, starting at pi over 2, and then every pi units because, again, its period is pi. So it's pi over 2 plus pi k, where k is an integer. Notice it starts right at the origin if there hasn't been any shifts, and we won't ask you to do any translations with the tangent curve. So my domain is all real numbers except where we have asymptotes. So it's all real numbers except where asymptotes occur. And then your range is all real numbers. It goes to positive infinity and down to negative infinity. Now, is the tangent curve even or odd? Well, is it reflective over the y-axis? No, so it's not even. If you spun your paper, turned it exactly upside down 180 degrees, you would indeed see the same thing. You would see it, all those points the same with respect to the origin, so it is an odd function. It has symmetry with respect to the origin, or it has specifically point symmetry or rotational symmetry 180 degrees. All right, so now let's practice up here. This is practicing with our sine and cosine curve. So remember, the number in front of sine or cosine is associated with your amplitude. Our number in front of the x minus is associated with the number of cycles in one period. Then we have our minus h, that's our right or left shift or horizontal shift, and then our plus k is our vertical shift. The period for cosine and sine is 2 pi over b. In order to find the period for tangent, it's pi over b. So let's look at this function right here. The amplitude. What is the amplitude? Well, the amplitude is always positive. The negative sign here tells us that we're going to have a reflection over the x-axis. Right? It's a vertical reflection, which means it's up and down reflection, so it's reflecting over the x-axis. But the amplitude itself is just 3. The horizontal shift, it's going to move left pi over 4 units. Why left? Because we want to have a minus sign here. So it's minusing a negative, so therefore moving left pi over 4 units. Our vertical shift is moving up 1 unit. So we're going up 1. Our period we can find by taking 2 pi divided by b. Well, b is equal to 2. So our period is pi units. Our domain for sine is always all real numbers, or from negative infinity to infinity. But our range this time is a bit different. We have to figure that out. So remember, this plus 1 says we're going to shift, instead of being at the x-axis, we have to shift our midline up to positive 1. And then from there, we're going to stretch up and down 3 units. So we're going to go up 1, 2, 3. So we're now at 4. So remember, this is 1, so we're going to go down 1, 2, 3. So we're at negative 2. So my range is from negative 2 to 4. All right, moving on, we have our amplitude and periods. Number 2 says determine the amplitude and period and describe all transformations for this tangent curve. So f of x equals tangent of 1/2 times quantity of x minus pi over 6. So tangent doesn't have an amplitude because there is no vertical, or there isn't going to be a maximum and minimum. So there is no amplitude for tangent. The period, remember, is pi over b, and this time our b is equal to 1/2. So it's pi divided by 1/2, which is the same as pi times 2 over 1. So our period is now 2 pi. And so describe all of our transformations. Well, we're going to have a horizontal stretch because the period has gone from pi units to 2 pi units, so it's wider. And then the last thing you need to talk about is the fact that we're going to shift the entire graph or translate the entire graph to the right pi over 6 units. And that's it. Okay, your next section here, I would pause and read through this to help you review. If you're coming from a different school system and you haven't done much with trig, then you should really pause and probably get in to see your teacher or go to Khan Academy and watch a few videos. But you probably need a little bit of extra review or practice. So you need to seek out your teacher to get that assistance. For those of you coming from SAS, you learned this last year in Algebra 2 Trig. So this is just a review. So pause right now and have a little read through it to remind yourselves of those trig, how to graph. Okay, so what I want you to actually do now is to kind of pause again and try to graph this on your own. So pause again, try to graph it on your own. I'm going to do the same thing, and then I'll walk you through how I graphed it. But I want you to pause it, try it on your own, refer to that back of the bottom of the previous page if you need some assistance. Okay, so here is what your graph should look like in the end. So what did we do? I had to shift from my midline to the left pi over 4 units. I had to adjust my period, 2 pi divided by 2, so my period is now pi units. So once I shifted to the left pi over 4, I counted pi units later. And I kind of made these vertical dotted lines to figure out how long a sine curve period would be. I then did this right here, my 3, I didn't really emphasize that, sorry. This 3 is my amplitude, so after I shifted up 1 unit, I forgot that part, sorry. I shifted up 1 unit, made my new midline, and then I had a 1, 2, 3 vertical stretch for my amplitude, and a 1, 2, 3 vertical stretch downward for my amplitude. Then I shifted to the left, readjusted my period, and the last thing you have to do is reflect over the x-axis. So instead of starting by going to your maximum for the sine curve, which we would normally do, you have to do the opposite because we flipped it upside down vertically over the x-axis, and we have to go down to its minimum, then to its maximum, minimum, etc. So it needed to look something like this. We want you to know that if we provide a graph that's this long, you have to complete that sine curve or cosine curve throughout the entire graph. So fill out the entire graph. You can't just do one cycle and that's it. You have to keep going and fill out the entire graph. So if you didn't do that, you might want to pause and do that now. Okay, the next section is matching. I'm not going to tell you how to match. I want you to pause, do that on your own, and then while you're paused, go ahead and try example 5. So I'm going to pause and do both. So you do the same. All right, for your matching, did you get B, C, E, F, D, A? If you did not, pause and try to figure it out. Hopefully you did. And on your cosine curve, did you shift your midline down 2 units? Did you stretch your graph up 2.5 and down 2.5 from the midline? Did you shift your graph to the right, pi over 6 units? Did you adjust your period to be 4 pi over 3 units? And then did you start the cosine curve at its maximum? And did you continue it all the way through the entire graph? So hopefully you did, and it looks like this. That's all we have time for right now in this video. Or you can pause. Actually, why don't we finish this up? So pause and then check this graph out. Okay, so if you look at your graph, you should have something that looks like mine. Again, your maximum is 4, minimum is 0. The period was 4 pi units, so it's stretched all the way along this entire graph that we provided. There's only 20 seconds left, so I'm going to show you the bottom one as well. If you need to, you can pause and look at that more carefully. The bottom one, you had to identify what a good trig function would be. I chose to make it a positive cosine curve by starting at its maximum and at its maximum. look at your period, make your adjustments, check it with mine.